Hello, everyone, and welcome to the second live class for backend development with Python and MySQL. My name is Mildred, and I am your instructor for this course. If you've not watched last week's live lesson, I will encourage you to go through your videos, your YouTube videos in the classroom, and then try to watch that video. For those in batch C, you only need the first 1 hour of the video, and then for the rest of the classes, you need all of the duration of the video. Now, this is also a combined class again for those in future batches to be able to revise topics that have been taught in part 1. We're going to start with the MySQL topics, grouping data and subqueries, and then we're going to move on to Python topics if we have people in the advanced batch on this live class. All right. So if this is your first time joining us, we meet like this every Friday to discuss in details topics that were posted in your pre-recorded videos. We upload videos for batches A and C every Friday, and then we have live classes for those classes on Friday. When we have combined classes, we meet at this time, and if we don't have combined classes, we have class for each batch. You will find the time in your classroom for your own meetings. We also have assignments that are due every 2 weeks for those in course 2, and then for course 3, we have set due dates for the different assignments. Assignment 1 is due today, and we unregister students after the first 3 weeks, which means by next Friday, students in batch C who have not participated or submitted assignment 1 will be unregistered from the course. Those that remain in the course will be given an invoice to make the payment to continue to week 30 and earn a certificate. Other information will be posted in the classroom. All right, so let's start. So today we are going to be looking at how to group data or aggregate data, and then we're also going to look at how to use subqueries to get a result from another query. Can everybody hear me or see my screen?
Yes, I can see your screen on here.
I hear you.
Okay, thank you. All right. So we're going to be using the classic model database. In your pre-recorded videos, we use the secular database, and the reason we're using 2 different databases is so that you can have a wider range of examples and to be able to work with different databases and not be stuck to understanding of just one database. As we get into the end of part 1, by next week, we'll start creating our own databases and look at how to run queries against our database. But for now, we want to work with databases that exist and see how we can run different kind of queries for different kind of real life scenarios. So we have something called the group by clause. We touched on it a little last week, where we say that when we want to aggregate data by a particular criterion, and we want it to return 1 row for each of that group or that aggregate, we use a particular clause called the group by clause. Now, in the classic models database, we have the customers table, the employees table, the offices table, other details table, others, payments, product line, and product. You can select all from each of these tables to see what kind of data and what columns this data holds. If you are using PHP-MyAdmin, you can easily just click on them without running queries. If you are using MySQL Workbench, you have to select all from table name. So we have the customers table having all of these columns. We want to let's use the payments table for this example we want to do. What we want to do is we are looking at the customers. We want to look at the payments that each customer has made. Now, when we look at customer number 103, they have different orders that they have paid for, or this customer has different orders and have paid different amounts. But let's say we don't want to see it differently. We want to have the total amount of money that this customer 103 has spent. Now we have a condition. We want to get or as a condition to aggregate by. We want to get all of the payments, the total amount paid by customer number 103. So in real life scenario, you can have things like this, or for instance, you have data and you are asked to check all of the clients or all of the people whose age group is between 20 and 24, for instance, and maybe they have their date of birth there, and you want to now aggregate to say you want to select everybody whose age group is in a particular range of ages there. So those are the kind of real life scenarios. So we're going to do this using this payments table, and we're going to get the total amount spent by the customer, each customer. Now we're also going to look at different kind of aggregate functions that we have and different clauses we can use to uniquely select from a table, especially when we have identifiers like this that repeats more than once. And let's say, for instance, we want to get the total number of customers. This is going to, when we say select and we group, we're going to get the wrong figure, except if we uniquely select, because it is repeated. So we're going to look at that now. So let's say we want to get the total amount spent by customer on all orders, and we want to write a query. So I'll go to my SQL tab here, and then I'll say select. Now it's not case sensitive, but by convention we want to write all SQL keywords in uppercase and then table names, column names in lowercase. So say select, and the name of the column is customer number. We also want to get the total amount that has been paid. When we go to the payments table, we have customer number and we have amount. So we want to use these two columns. So I'll say select customer number, and I want to also select now I'm going to aggregate because I want to get the total amount. So I'll use the aggregate function sum. And what am I going to sum? I'm summing the amount column. So sum amount, and I want to alias this, because remember in last week's lesson, if you don't alias, you're not going to get a nice looking column name. You get the column name sum amount. So let's say we want the column name to be total spent, like this. And we're getting this from a table called payments. And what we want to do now is to say we want it to total all the amount spent, all the money spent by a customer. And because we are trying to get the total amount paid by a customer, we need to group by the customer. So you're grouping by the column of interest. So we use the group by clause, and we'll say we are grouping by customer number. So let's go over this again before we run to see if all is well. Whenever you want to aggregate a particular data, there's always a column of interest that you are aggregating by. If the column of interest, for instance, you want to group and say we want to return all the customers whose gender is female, so the column of interest is gender. Now we want to get the total amount spent by a particular customer. The column of interest is customer, and so we're going to be grouping by that column of interest, which is customer number. And when I say go and all is well, I'm going to get the total spent for each customer. So now we can see that this is not repeat. We don't have repeated customer number as we had before. It just aggregates them, give us the total 103 spent, 112 spent, 114. So you need to practice this and give yourself several scenarios to be able to learn how to run these queries in different scenarios. So the syntax is select column names. If you need to aggregate any column, research all the aggregate functions that we have in MySQL. We have sum, we have count, we have average, refer to last week's lesson, and also we are going to touch on it in next week's lesson. the different aggregate functions that we have and what we use them for. And then the syntax is select column names, and if you want to aggregate, you put the column name in the parentheses of the aggregate function. And if you want to alias, once you aggregate, you want to use the has clause and give it a new name that you want it to be. Whatever name you want to give should not have spaces. If it has spaces, you have to quote, or I use an underscore to separate two words. And then from the name of the table, and then group by the column of interest. Now we've gotten this out, and let's say, for instance, we want to do something like give a discount to customers that spend, let's say, over 100,000, or we want to say the ones that spend less than 100,000 are not customers of interest. We want to get those customers. For instance, let's say we want to add a condition to this group. Whenever you're adding a condition to a group, we use the having clause. And so I'll copy this so we don't have to type it all over again. I will say select customer number, sum amount has total spend from payment group by customer number. But now I want to say, when it selects all of this, we want to say having the total spend now. So we want to see if the total spend is less than 100,000. That's what we want to return. So we say having total spend less than 100,000. So whenever you want to put a condition on a grouped data or on aggregated data, you want to use the having clause after the group by clause. There are other ways you can do this, but this is the easiest and I think the most professional way you can do that. Writing using the group by and then the having after. So the syntax is you select the column names. If the column should be aggregated, you put that column in the parentheses of the aggregate function. From the table name, group by the column of interest, having the column you want to specify the condition on, then the condition. So you can say less than 100,000, greater than, equal to, whatever you want to use here as the condition. Look at the different MySQL operators for you to see how you can compare two things or how you can specify conditions. And when we say go, now we're going to have only those that spend less than 100,000, and we're not going to see any column here that is 100,000 or above. Okay, anybody with question?
No question for now.
Okay. All right. So if in this same scenario, we want to get the total number of people that spend less than 100,000. We don't want to get the total number of people. Now we have gotten each of the customer that spend 100,000. We use the sum aggregate function. Now we want to get the total number of people itself. This is a different type of aggregate that we are going to get. So now this is where it gets a little confusing. Now MySQL is not difficult. It can be confusing. You need a lot of practice to be able to knock out that confusion. You need to always work on it for you to be able to naturally just write queries without even thinking. So we're saying that if in this same scenario we want to get the total number of people that spent less than 100,000 in total, we can do something we call subquery. Now when we have subquery, it means that we have a query inside of a query, and then the outer query is going to pull its result from the result of the inner query. And so let's say we want to get the total number of people. Now let's look at this payment and what we just did before. What we did before is we get this customer number repeated several times here. If we want to count the total number of customers and we do something like select count, and it's the customer number. From, let's say, payment. Now, we want to say we are selecting the total number of customers that made payment. This is going to be wrong. The answer we'll get from here will be wrong, because, and I'll tell you why this is wrong, and this is where you have to be careful. We'll get 273, but we don't have 273 customers that made payment. The reason we are getting 273 is because it is counting each row of data, and the customer itself, 103 is three times they made payment. 112 made 3 times. 114 made 4 times. So we can see that some of them are repeated. So this is the scenario where you want to uniquely select customer number. Customer number 103 belongs to one person. You don't count that person more than once. So in the events where you want to uniquely count somebody, the person has done the same thing several times. And one of the real life scenario is, if you want to say, for instance, the number of people that you have, all of this, that maybe you have a classroom and you want to say the total number of students in the class. And then in that same scenario, you want to say the number of students that likes oranges, the number of students that like apple, the number of students that like bananas. Now, you might find one student that likes all 3. You might find one student that likes 2. And if you decide you want to get the total number of students by adding the number of that likes bananas, that likes apple, and that likes oranges, you will now get the wrong total number of students, because now we have repeated occurrence of those students there. So the best way to do this is to uniquely select customer number. So how do we uniquely select? We use a keyword called distinct, like this. When you say distinct, and in the parentheses you put the column that you want to uniquely select. So let's write a subquery that we can use to do this. And so we want to uniquely select customer number, like this. So the query is going to be select. Now we want to select the total number of customers. So select count, we're counting the unique number of customers. So unique customer number means distinct customer number. So notice that we put the count aggregate function first, and then in the parentheses of the count aggregate function we use the distinct keyword, and in that parentheses we put the customer number there. So we're selecting count distinct customer number, and let's say we are saying this is has, let's alias this, let's say as total customers, and we're selecting this from the payments table, and we'll say where customer number now. For subqueries we have the in keyword. Now we're going to look at all of these different MySQL operators. I think we've seen them in our pre-recorded videos, but we're going to go into more details in next week or the week after. And when we say in, we just mean if this whole query, which is the outer query, we are running this query against a query we are going to specify in this parentheses. So if we, first of all, we always want to write the inner query so we don't get confused. And the inner query we want to write is to select the customer number from the payment. We want to group by customer number. We want to have the total amount less than 100,000, like we did in the first group query. And then from that result, we want to uniquely count the total number of customers that made payment. So we're selecting uniquely counting the total customers from the payments table where the customer number exists, or where the customer is part of the customers that made payments less than 100,000. So let me rephrase that again. We want to get, okay, I'll delete this and write it back. First of all, we want to get all of the customers that made total payments less than 100,000. We did select customer number from payment, group by customer number, having sum. Now I'm doing this a different way. The first time I did select some amount from here, but now I'm putting the sum amount in the having clause, and I'll tell you why I did this. MySQL is going to error out if we specify one, or we specify more than one column here, and then the operand now is now, or we specify one column here, and then now in the condition we have more than one column. It's going to tell us that we should specify only one operand. When you compare the two query, when you rewatch this video, you understand why I changed the query. It will still give us the same results, but I want it to keep to the rules of MySQL, where when we specify one column here, we have to make sure that whatever we are getting from the outer query is also looking at one column. So we can't use two columns there and now use we can't use two columns here in the inner query. We will get an error with MySQL. Okay, so select customer number from payments group by customer number having some amount less than 100,000. That's what we want to do. So this one will return all of the customer numbers that have made payments less than 100,000. So this is what we want to get. Now from this result that has just the customer number, there's something we want to do. We want to select or count the total number of customers. So we've returned the customer that has amounts less than 100. We want to select the total number of customers. This might not make very good real life sense, but it just shows you how we run SubQuery. So you put this in the parentheses, and then you write an outer query that will say select count, and now we'll put the distinct customer number, and we're selecting this as total customers. And we're selecting this from payments, where customer number in, so where the customer number is returned from this query. So that's what this means. We want to count the unique number of customers from the payments table where the customer number exists in the results of this query. So we are not actually counting the total number of customers. We are only counting the total number of customers that have made payments less than 100,000. So we've used a subquery. So what subquery means is that we have an outer query, which is this, that gets its result from the result of an inner query, which is this. So when I say go and all is well, we should get the total number of customers, 73 customers. Okay? Anybody with question?
Hello.
Yes.
I need you to go over the inner query again.
Okay. All right. So let's do another example to see. Let's use a real world scenario to explain this, and then we'll redo maybe something different so that you can see different examples. Let's say you have a classroom of students and you want to get the students who are going to be promoted to another class, and let's say the pass mark is 70. From those students, you want to group them by male and female students. You want to know the number of males that are promoted and the number of females that are promoted. Now, the best way you do this is with a subquery, where you say you want to select all of the students whose total score is greater than or equal to 70. That will be your inner query. And then your outer query is now to select all of the students grouping by their gender where that student exists in the result of the inner query, something like that. So it's when you have more than one condition and you are looking for a way to be able to get a result out of a result. I want to get all the males out of all of the people who scored greater than 70 or equal to 70. So anytime you have this kind of condition that seems like you are trying to get a result out of a result, that's the time where you think about subqueries. So you want that first result to be the outer query, and then the results you are selecting from will be the inner query. Here, what we were trying to do is to get all of the customer number from the payments table that have their total amount spent for all others less than 100,000. From that result, we want to uniquely count the number of customers that exist. There's a straightforward way, one-line query to do this, but I decided to use this as a subquery example. So we have two conditions. First of all, we want to get the total amount spent by customers. And we also want to put a condition on these amounts to make sure that we return just the customer numbers that have spent the total of less than 100,000. When we get this result, we want to count the total number of customers there. Let's do this again. So the first thing we want to first of all do is to get the total amount paid by customers and return only the ones that have spent less than 100,000. So it will be select customer number from payments group by. So the column of interest is customer number. Now we want to put a condition. Once you use a group by, once you use group by, the condition has to be having.
Having, okay.
Yes. Once you after a group by clause, any condition on the group's data, you use the having clause.
Okay.
So you say having some amount, so we're aggregating the amount, and we want to say this is less than 100,000. So we've gotten the inner query condition.
So this inner query is trying to select customer from the payments table, and we are grouping it by the customer number that what they spent is less than 100,000.
Yes.
Okay, go on, go.
Okay, so because this is an inner query, you want to put the query in a parenthesis, and then we want to get something out of this. We want to count the total number of customers, and the total we are counting is not all the customers that exist, but just the total number returned from this query. And so in the outer query, we are going to say select. Now we use the distinct clause to be able to uniquely count the customer, because when we have repeated customer ID, customer number, we don't want to count it one person more than once. So when we use distinct, it counts every customer just once. So if it says 103 10 times, it just counts 103 once, and that's why we use the distinct clause. So now we want to count, so we use count, and then in the parentheses we want to uniquely count, we use distinct, and we are uniquely counting the customer number. So we say select count distinct customer number, and we're doing this from the payments table. So now we're using the where clause where the customer number exists in, so use the inner query.
Okay, ma. The distinct is, if we don't put that distinct, there will be repetitions, right?
Yes, it will count it more than once.
Okay.
So to count each customer more than once, and then you're not getting the true representation of how many customers. You are getting how many times all the customers are listed. So one person will be counted more than one time. But once you have repeated numbers, like you have a unique identifier, you want to count each person once, you use distinct. Let's say, for instance, there's a census population.
Okay, ma. In a scenario where we want to know various times that customers made payments, are we still going to need distinct?
No, you don't need distinct because you want to count every occurrence.
Okay, it's okay. Yeah. It's okay.
Yeah. So once you go over the query over and over again and several times, try to break it down and write the query section by section. Now decide which query goes in the inner and which one outer. Now, in is not the only keyword we use. We're going to, as we go deeper, see different scenarios where we use between and some other clause here. But when we say in, it just means that it is part of this. It is a result in this query. Okay? So, if we look at the order details table, for instance, you can see here we have repeated order number 10 in 100. This person ordered in this same order. So let's say in the person's cart, the cart is what is giving the order number, and the person has several items in that cart. Now this order number might have been named from one order that was placed at once, but there were several products in that order, and for each product the person will select a quantity. So if we want to buy something, you have 30, 50, 22, and they have just the individual price quoted. You want to find a way where it just gives the total amount for the order. So instead of having each price 136, this person ordered 30 of this. So what's the total cost of this? The person ordered 50 of this. What's the total cost? Within the same order, the person ordered 22 of this. Within the same order, 35 of this. So now what is now going to be the total amount paid for the order number 10,100? Because we have it repeated 4 times here. There are different quantities and the unit price are specified. We want to get what the total amount for order number 10,100 is. Now we can still use the group by clause to do this. So I'm trying to just give you different scenarios where you have a beautiful front end. You just click on an order, you see total amount paid. Something is going on in the back end to give you that calculation. This is where the query runs to get you that. When you enter or click on an order number and you want to see the total amount for that order number, what is the code behind the code? So when you click on it, it sends something to the back end. Python processes it, requests the information from the database, returns it back to Python, passes it back to the front end. That is what happens behind the scene, and we're going to see that in part 3 of this course. And for those of you in batch A, we are crossing over to part 3 next week, and so we'll begin to develop a software that shows you all of this, how to connect both front end and back end together in this type of scenarios. So we want to use this now to say we want to get the total amount paid for a particular order number. Let's write a query to do this. So we'll say select. Now the column of interest is the order number. So we'll say select order number, and we want to also aggregate. Let's look at the columns again. I've forgotten. And we have quantity ordered and price each. So we want to say, for us to get the total amount for this particular line, we'll want to say is price each times quantity ordered, right? So that would be the normal. If you're using your calculator, you're saying 136 times 30. We want to put this in a query. So we'll say select, and we're going to select order number. We select now aggregate sum. We use sum, and we want to calculate the quantity ordered times price each. So we'll say quantity ordered times price each, and we are doing this. Let's say we alias this as total. We are doing this from the order details table, and we are going to be grouping by the column of interest, which is order number. So this is just what we need to get the total cost for a particular order. And when we say go, we have the order number 10,100 and the total amount for that order is there. So for each order number, we get the total amount. So this time now we are not getting duplicates for an order number listed several times and the quantity ordered and the price each. We just get the total amount for the order, regardless of the products that are there, just all the total amount.
Now, in the table you showed us for the order number, we have like 3 or 4 for 1,000. So
Yes.
in essence, that summed up everything here for 1,000.
Yes. So we have 10,223.83. If we come back here to say you want to use a calculator to multiply this by this, this by this, this by this, this by this, and then add it together, that's what that query just did. So it saves you the whole headache of doing the multiplication and then adding everything together.
Okay, thank you.
Okay. But what if we want to do something that we want to put a condition and say we want to get the orders that the total is less than 100,000? We do the same thing. We use the having clause. So we're going to be, let's write the query back. Sorry. We'll select order number, and we'll do the sum of the quantity ordered times price each. And let's say has total, and we're doing this from the order detail. Group by order number. Now we use having. So remember that every time you want to put a condition on a group data, you use the having clause. So we say having total less than 100,000. And so when you do this, you will now get your result filtered having only result less than 100,000. So we are not going to get anything more than 100,000 or 100,000 and above here. So everything returned here will be less than 100,000. But what if we say greater than 100,000, for instance? Change this to greater than. Let's see if we have anybody who spent more than 100,000. We don't have anyone, so we have nothing returned here. If we say something like 50,000, then we'll have some rows returned because we have people who spent. We say less than. Let's say greater than 50,000. I mean, it's 500,000. Let's say 50. Sorry. So I'll copy the query. Let's say greater than 50,000. And then go, and then we have just people who spend 50,000 and above. So we don't have the other numbers with less than 50,000. So these are the different conditions you can specify depending on what you want to do. You want to group customers according to platinum customers, gold customers, and different things that you have. These are the kind of queries that you run. Okay?
Yeah, thank you.
You know, we can also have the order numbers from the orders where the total is less than 100,000 in a different kind of query. Let's say, so sometimes two people will write query for the same thing and the queries will be different, but they will do the same thing. So you just want to make sure your query is optimized for performance. It doesn't matter how you write your query as long as it returns the correct result and it is not creating performance issues. So let's say I want to do select customer number, and I want to select order number again. Okay, so what I want to do is I want to write this query first and then just see different layers of having nested subqueries, not just an inner query and an outer query. We can have several inner queries. So let me write this thing, then I'll explain it for you. So I'll select customer number, order number. I'll select this from, let's say from orders, where the order number in, then I'll write an inner query, select order number from order details, group by order number. Now use the having clause, sum of quantity ordered times price each is less than 100,000. Okay, so what I'm trying to do here is to get all of the orders from the order details table, and because the column of interest is the order number, I'm grouping by the order number, and I want to say that I want to get just the order number for the orders that have the total amount for all the orders in that order number less than 100,000. And then when that result is returned, I want to select the customer number and the order number from the orders table, from a different table now, where the order number is contained in the result returned from this query here. So I'm going to be getting the customer number and the order number from the orders table, where the order number exists in the result of all of the orders that are less than 100,000. Yes, so that's what this subquery is doing. So when I go, I will get the customer number and the order number. Now we know that all of these order numbers that we have here is less than 100,000. But you see that this is not aggregated, it's not unique anymore, because this customer has 3 different orders. And look at the order numbers that this customer has. So here you know that customer number 103 has made an order 3 times. And these are the order numbers that the customer has. If you want to go further to add the amount spent for each of the order for this customer, you can also add that. What if we say we don't want just the customer number, we want to know the name of this customer? This time when we do that subquery, it will now end up giving us this uniquely, because we are trying to get the name of the customer. Now, sometimes we write query, you think it makes sense, you think it's correct, until you begin to think about it over and over again, and then you now begin to see that I should have done it this way. This is not correct. This is correct. And that's why in things like writing queries, you need teamwork and group work. Something that you're very sure is correct will now be flagged by someone telling you that the logic here is not correct. So logical reasoning is what is needed here. So let's just do something here. we want to use this query, all of this query as an inner query. So you can see that we're using both the outer and the inner as an inner query. And we want to just get the customer number and customer name from the customers table where that customer number exists in all of these results. So we'll say select customer number, customer name from customer where customer number in this result. So this is the outer query. This is the inner query. This inner query consists of an outer query and an inner query. So you can nest as much as you want. Just make sure that performance is guaranteed. And when we say go now, we have operand should contain 1 columns. Now this is the error I wanted to illustrate, where when you have your inner query having, you see this inner query is having 2 columns, it's supposed to have 1 column. MySQL will give it this kind of error. When you see this kind of error, that is the reason. So how do we change this? So we now change the inner query to have select customer number. We'll remove order number from here. From orders, where order number in, select order number from order details, group by order number, having some quantity ordered times price each less than 100,000. So because it will not allow us to put 2 columns in the inner query, we have to use 1 column. So this time we'll get it right. So we get each customer number has the customer name. So now it's not repeated several times. It automatically knows from this query that this person is unique. There's no need to have it 2 or 3 times. So you see in the first query, we had the customer number repeated several times, trying to get all of the other numbers. But after doing all of the inner query, what we want at the end is just to get the customer number matched with the customer name. And we only want this for orders that the total order for each of the order number is less than 100,000. And so we get
it's a rule that there must not be 2 columns in the inner query.
Yes, it won't go. You'll get the errors. So I want you to try it out and see the different errors you will get for different scenarios and try to interpret the different error messages.
Okay.
All right. Anybody with question? Okay, in the absence of question, this is where the lesson for batch C ends. And let's see if we have students from other batches for Python here. Yeah, we have students for Python. So if you want to go ahead to learn some topics from that you meet in part 2 of the course from week 8, you want to understand in advance, you can hang on. But if not, if you're just for Web Dev 0224C, you can now log out if you want to, or you can hang on to continue into Python. So for today's Python class, we're going to be looking at object-oriented programming. And the reason I chose this topic is because I noticed that from grading assignments, this is one of the topics that was not well understood from the pre-recorded video. So we're going to look at it in deeper details and see if we can establish a better understanding of object-oriented programming in Python. So I'll give us like a 5-minute coffee break, and then we'll come back and we will start this. All right, everyone, welcome back. So we're going to look at object-oriented programming in Python. And when we talk about object-oriented programming, it just involves grouping related properties and behaviors into individual objects, and we use classes as the blueprint for the creation. Now, when we say we have classes, it just allows us to define functions, which we call methods. So when we have functions within classes, we call them methods. For instance, let's consider a person. Anybody is called a person. Now, everybody has characteristics and behaviors. We call these characteristics the properties, and we call the behaviors like the methods. When we take the person class, for instance, we want to say the class person is just like a blueprint from creating real people. So let's just say like we have an empty form. We distribute forms or questionnaires for people to fill. Those forms are classes. When the form is filled out, we now call it an object, because now it contains real information about real people. Every time we have an instance of a class, it is an object, because an instance will now hold real information about that class. So let's consider the class called person. We can create an object out of a person, and each object of the person class has, or everybody in the person class has properties like their name, their sex, their race, their behaviors like walking, talking, running. So when we want to define a class, for instance, we use the class keyword like this with a name that we have given this class. In this example, we're using the person class. And then we put a colon, and then we start the definition of this class. This is a blueprint. The person class is a blueprint from which we create real persons, which are now objects of the class. The properties like name, sex, race, and behaviors are something that everybody has, but the value for these properties is what differs from person to person. And those values are what we define in an object or the instance of the class person that we're going to create. When we define a class like this, we want to consider something we call attributes. Now, we have two types of attributes. We have the instance attributes and we have the class attributes. Now, when we create an attribute, the first thing we want to do when we create a class is to have the init like this. Anything we create using the init method is called the instance attribute. So we'll do def init. Def is what we use the keyword to create a function. So the init one, when we use init, what we are saying is that the property of all objects must have this init method. We call it, this is what is called automatically every time we have a new object of the class. We must have this init method. And the first parameter here is always self, and then we now begin to define the properties of the person class. The person will have a name, the person will have the sex, the person will have a race. Now, we want to now define these properties. So say self.name is equal to name, self.sex is equal to sex, and then self.race is equal to race. So let me go over this again. The class is the blueprint from which objects are created. We have a person class. We want to define this. Let's take this person class as a blank form that is distributed for people to fill in their personal information. When this form is blank, it is a class. When it is filled out, it is now an object of the class, because now it has real information. Now, we will have on that form first name field, last name field, sex, race, all those fields. These are properties that every person has. But now the values that will be filled into this field is now what makes one person different from the other. That's what makes each of its different objects of the class. Is it understandable?
Yes, it is, ma. I need to ask a question.
Okay.
Now, why class in what's it called? In Python. Why class? What do we want to achieve with it?
Okay. So when you have object-oriented programming, it actually makes programming better. It gives you more control. In other programming language, you have something like private, public. It gives you different kind of control, different inheritance. It's just like a blueprint. It makes it easy. So you don't have to always come and create something new all the time. When you have a blueprint for that thing, you just fill it out. So if you don't have a class, for instance, every time you want somebody to give information, you have to create a form for that person. But when we use classes, it makes the process streamlined. You have just one class blueprint and everybody just photocopies the same paper and uses it. But in the absence of a class, then you have to do it all the time for everybody. So that's just the way I can explain it in basic terms. So when we go deeper, you now see, you begin to compare and see how useful it is. And then if you have a class, let's say, okay, we'll do that example as we go along. I'll try to put that example in. If we didn't have a class called person that has a name, sex, race, let's say, for instance, we'll have another class later called pet, for instance. We want to see which pet belongs to which person, right? Now, we're using these classes, we are able to inherit properties and methods from the person class, and we're able to define something we call attributes. We can have instance attributes, we can have class attributes. It makes our code shorter, neater, easier to maintain. And so by the time you come and change the definitions in a class, then it changes everywhere. So let's say, for instance, you don't have class, you have just forms printed for each person. And at some point you want to add a new field. You have printed this for 1,000 people. Then you have to now change it for the 1,000 people. But when you have a class, you change the definition of the property on that class and it applies everywhere. Is it understandable?
Yeah, I'm trying to get that. You said we change it at the definition. I don't get what do you mean by that?
Okay, like now I come here and I want to add a new property. For instance, okay. I want to add something like language.
Okay.
Just come and add it here and it applies everywhere. I define language here to be self.language is equal to language. Now this will apply to all the blueprints automatically. So if I've printed 1,000 forms, automatically this adds to the 1,000. But imagine there is no class. You have to pick each 1,000 form to start adding language field for each of them.
Okay, I think I get it.
Yeah. So we now have the definition. We say that every class should have an init method like this. The first parameter is self, and then all the properties for the class here. The properties are something you decide. If it's a car, for instance, you want to write maybe the make, the model, the color, the weight, or and all of that has properties. And then you specify behaviors. Behaviors are different, something totally different. So when we say self.name, this will just create an attribute called name and assign the value to it. So anytime you call up this, the name you specify as the argument is going to be attached to the name. So that's what just this means. Okay, so we say something like we have an instance attribute and we have a class attribute. When we use this init method, attributes that we create using this init method are all called instance attributes. These instance attributes are attributes that have values that differ.
Sorry, man, you said something. Attribute we create with what? Init. I need you to repeat that, please.
With this init method. All these attributes that we create with init method, name, self, race, are all called instance attributes. And why they're called instance attributes is because their values differ for each of the objects. So from person to person, the name differs, the sex differs, the race differs. So anything that has different values for different people, it is called an instance attribute.
Okay. It's
now
not common, it's different.
Yeah, it's different. So we call all of these instance attributes just because they have, when we create new objects of this class, different people will fill out different name, different sex, different race. They're called instance attributes. Then we have class attributes, and class attributes are the ones that have the same value for everybody. Let's give you an example. Now we're creating let's say a medical record form or something like that, and we want to collect information of people that walk into the clinic. Now, for you to walk into the clinic, you have to be alive, right?
Yeah.
So we want to create a class attribute called status equal to alive. So this applies to everybody. Everybody that walks in is alive. So the value of this status attribute applies to every object of the class we create. So every form we give out is going to have the status of alive automatically until we change it to dead if we want to. But because we know that everybody who walks in is alive, we use a class attribute to specify this value so that we don't bother specifying it for every object. So when we give out those forms in our scenario, we don't need to specify status alive. Anybody filling it out has to be alive. So we automatically know that all the objects created are alive.
Okay, sorry, man. Let me just be very naughty. What about if they brought somebody in and the person is already dead before he got into the hospital?
Okay, so when the person comes, the status was alive and the person later dies. That is where we will look at the example where we change the class attribute value from the default to a new value. So that's where we will change it. Okay. And we're going to look at that as we go along today.
Okay.
Okay? So every time we create a new object of the class, this init will set the initial state of the object. So you can give it any number of parameter, but the first parameter that we have here will always be self. We use self to define the attribute self dot the name of the attribute self dot until we list all of the parameters that we have there in the init method here. When we instantiate the class, that means we are creating objects of the class. It will have different values for the properties. So let's say we want to store information about 4 different people, for instance. So we're going to have, let's say the name of this variable we're going to create is going to be Jane. And Jane is going to use the person class as a blueprint. And in the parentheses, we'll specify the name, the sex, and the race. So let's say the name of Jane now, we'll have the full name, Jane Doe. Then we now have the sex of Jane will now be female. And then we have the race, let's say Latinx. That's one person. So you can see how we have used this class as a blueprint to create new objects. We store these objects in a variable Jane, and we'll say Jane is equal to, we call the person class in the parentheses, specify the parameters name, sex, race. We can do the same thing for another person, let's say John.
Sorry, ma'am. The self is not defined in the attribute, in the variable we are setting for J.
No. How will I describe self for you? It's like, for those who did course 1, self is like this. It just refers to the method itself or to the object itself.
Okay. So it's a constant.
It's a constant that has to be there.
Okay. It's okay.
Yeah. So we'll say person and want to create another person. We'll say John. Let's say John Smith. And John is, let's say, male. And let's say the race of John is, let's say, black.
Sorry, I'm asking too many questions now.
No, it's
person, okay. Is it compulsory? Are we trying to say, okay, this Jane is a person?
No,
the person be there?
Yes, it must be there, because now we're using the blueprint class. So like our hypothetical scenario where you distribute a form and the form have different fields, there has to be a form for you to fill in something. So the person here is like the form, and this argument you supply are just now the values you are feeding into the different forms.
Oh, okay. Sorry, we create a class for person. Yes. In the first, right? Okay, ma'am. Assuming we want to create a class for maybe let's say cars.
Yes.
So in the place of person, then it's going to be car.
Yes, it's going to be.
Okay.
So like this. And then you define make, model, year. So car will be something like this.
Yeah. Okay, I get it now.
Okay. So we have another let's say we want to create another person, Jacob, and Jacob will use the person, and let's say we have Jacob, the Jones, and let's say Jacob is, let's say, intersex, and Jacob is, let's say, white. So we just bring hypothetical scenario. Let's stop at 3 people like this.
Okay.
So each of these is an object of the class. So you can see how we have used the person class as a blueprint to just supply values. And so this is why it makes it easy. Now you have a blueprint. You just supply the values for a new instance. Every time you create a new instance, that's new object of the class, you are creating a new person.
So the other time you talked about language. Assuming we include language over there, aren't we going to come down here again to include it?
So if you put language here,
yes,
right, we can put a default value equal to English, like a default value. And then when you say self.language is equal to language, when you come here, if the person's language is English, you don't even have to specify it. So if you are working in a particular region, let's say for instance, I come to a country that has just one language. So I know definitely that the default language, let's say the language of instruction is English. I want to put English as default. Except if the person is not English, then the person will have to specify a language now and say Spanish.
Okay.
But once you have a default, you don't even need to specify a language.
Okay.
But we're going to look at how we use this with a class attribute. So now we have these 3 persons that we have. If we want to access the values of each of the objects, we use a dot. Let's say for instance, we wanted to print the sex of Jane. We'll say print. Now the name of the object here is Jane.sex. And when we do this, we run, we're going to have female printed here because Jane is a female.
Yeah.
If we say Jacob.sex, it will print the sex of Jacob here, which is intersex here. So this is how we access the values for each of the persons. So now we talked about the class attribute status is equal to alive. Let's say that Jacob came in and Jacob died. How do we change the status of Jacob? We can come here now once Jacob died and say Jacob, the status is equal to dead. But before we print this, let me comment this out. I want you to see Jacob, the status first. By default, alive is assigned to everybody. Let me clear this and we run. We have alive. But by this time now, Jacob is dead. We come to say Jacob, the status is equal to dead. When we print Jacob, the status the second time, it's going to print out dead because we've changed the default value of alive to dead now. So when it changes, you just put the object name dot the property name is equal to the new value. So is it clear to everyone?
Yeah, clear from this angle.
Yes.
Clear. Okay. I've been having challenge with this OPP, object orientation. Thank you.
All right. Okay. So we can see how we do that. Let's say we want to print a statement to say John Smith is a male. We want to print the name, the sex, the race, and the status. So we can say something like, let's print for Jacob. So let's say Jacob.name, Jacob.sex, Jacob.race, and Jacob the status. We just want to print all of this out. So we should get the name, the sex, the race, and the status here. So we should see that Jacob is dead in the statement. So no, I used Jane, sorry. It's supposed to be Jacob here. And so we have Jacob Jones, Jacob Jones intersex white dead. So I don't know why this is printing Jones, Jacob. Okay, yeah, we're using Jacob, so it's Jacob Jones, that is the name. So Jacob Jones, his sex is intersex, the race is white, and the status we change it to dead, like that. So we have said that when we define functions inside a class, we call them method. We call them instance methods. All of these are called instance methods. We always use self as the first parameter. Now, we've done all of this. Let's try to say we want to, if for instance we say we want to print out something like, let's say, print Jane. Without the dots, we're not printing property, just Jane. So what we will be getting here is going to be the object's address, not what Jane holds. So we'll get person object at the reference address here. But we don't want this. But before we get to doing this in a more Pythonic way, let's do this like we're creating more methods first. And then we'll change this over to see how when we print Jane, we'll no longer get this. We have defined the init method, which we should always do first. We want to create a new method. Let's say, for instance, we want to create a method that will introduce the person. So let's say def, let's put the name of the function to be introduced, self, and we'll say, this should say return, hello, my name is self.name, and I am a self.sex, and then we want to also introduce self.race. So remember how we used recall how we used the format string in other lessons, just to be able to use placeholders with all of these variable names. So hello, my name is, you print out the name, the sex, and the race of the person here. Let's say this, when we call the introduce method, we want to get this out. Then let's say we want to print another method. So within the class, we call it method, but it's actually a function. Let's say we'll say def age, and this will also take, let's say, to take the name. So self is always first, and then let's say take date of birth, for instance. So let's take date of birth, and then we want to say this should return self.name. So we'll say return. We use the format string, and we want to return self.name, and then we say is born on, let's say, self.date of birth. So let's just use this. So say self.name is born on self.dob. Let's use dob. Okay, so self.name is born on dob, because now this is a parameter here. We specify it here. I'm not using self dots because I didn't define it as a parameter here. So self.name is born on dob here. So whatever we supply here when we call this method is what is going to be printed out here. So we have created all of these different methods or functions within the class. And now we have these different persons that we have created. If I say print Jane.introduce, that's clear. So I'll call introduce with the parentheses. So you say, hello, my name is Jane Doe. I am a female Latinx. What we want it to return here, because we are calling the method or the function of this object. We can say print John.introduce, print Jacob.introduce. We can print Jane.age, and then we'll put the date of birth there to tell us when Jane was born. So when we do this, we have the different printed out, and Jane Doe is born on the date of birth there. So you can see how we use the different methods to in different statements. So in real life scenario, when you have of class a blueprint, all the functions or all the methods that you want the class to be able to, that you want to call on the class, you want to be able to get the date of birth or calculate the age of the person from the current year minus the date of birth. We're not going to go into dates today. You can do that to give you the current age of Jane Doe. Like when you have like a hospital management information system, those are the things you see where the doctor logs in and on the care card you just see the date of the person. It automatically changes every year because it's using the current date minus the year of birth that the person has, and so it's going to be giving the age of the person. So we use this like this, and so when we print out Jane, we still get, let me say print Jane, we'll get our reference address. So I think that was the point I was heading to. And we don't want to get the reference address anymore. We want it to use the introduce method instead. So since this returns a string, right? And we want to do this in a more professional way, there is this $string method that we can use. So instead of saying introduce has the name of the method, we can just do. So this will return the string representation of the object. So when we change the introduce to string like this self, what this does is that we print out the object of the class and we get the introduction, and this just gives us the string representation. And so whenever we say print Jane, we're not going to get this object reference anymore. We'll just introduce Jane when we print Jane. So whenever we want to have a string representation of an object, we use this string dunder method. We're going to look at dunder methods sometime later. We call them magic methods. Anything that has a double underscore before and after. They have different purpose and different methods. Init is automatically run every time we insert the class. We have the string. This will give us the string representation of the object. Okay, so we change that to string. And so this is what you'll find most of the time in Python code. You won't find a function or a method like introduce. Instead, you find something like string, which gives us a string representation of the objects. And every time we call the object, we no longer get the reference address, but we get the introduction printed out. Anybody with question?
No question from there.
Okay. So let's say we have another class attribute that we want to add here. Let's say everybody speaks different languages, speaks a lot of languages. We want to put this in a list. Let's say everybody speaks. English is the default. So because language of instruction is English, so we'll just assume that everybody speaks English. So we will say Jane.speaks here. We are going to get English when we run this, because English is the language we put here. Now, assuming Jane speaks more than just one language, more than English, we want to append to this list. It's a list. This might not be the best way, but I'm just trying to show you how we add more things. In the event where it's not just one value, we want to add more things, like you speak several languages. So we want to say something like Jane.speaks.append Spanish. Let's say it's both Spanish and French. So now when we say Jane.speaks, we get English, Spanish, and French, because we have said that Jane speaks more than one language. So this takes exactly one, we use append. So let's use Spanish first, and then we append French later. So we have English and Spanish. If we want to append more, we say speaks.append French. And then we have English, Spanish, French, all at once. When we use the append method, we only have one argument we can supply, not several. Or we want to supply a list, but not several arguments like that. So we added Spanish and French to the languages that Jane speaks. If we go and print John.speaks.
By what?
Sorry? So because we have appended this might not be the best way to do this, but we're just showing you. So because we appended this to Jane, we're appending to the original speaks list. And so we've appended Spanish and French to that list. And so when we say something like John.speaks, it now automatically adds Spanish and French to John. Meanwhile, what we wanted is what Jane speaks, not to add it to the speaks attribute itself. So we appended the Spanish, French to this. And later on, we're going to see how we're just going to append to a copy and not to the original. So printing John.speaks now gives us English, Spanish, and French because we appended directly to this. So I'm showing you this to see the common mistake we can make is when we start testing and running tests that we begin to see that this is not giving us the expected results. And so we'll look at how, as we go into Super 3, not writing to the original, but to a copy of the attribute. Okay? Any question?
But man, what we did here, I don't know, maybe that's what you are trying to explain. If John is not speaking Spanish and French,
yeah.
So how are we going to do it? And we already say John.speak, and we have appended the French and Spanish.
Okay, so we appended French and Spanish to Jane, but what we appended to is the original speaks. And so anytime we call any of these objects, we are going to be getting all the languages that Jane speaks to everybody. So that's why I said, as we go deeper, I don't want to get into that today, because there are other topics I want to add to it.
Okay.
We're going to look at how you will append not to that, but to a reference of that. Okay. So I wanted you to take note of that before you go into using that, to see that when you append to the class attributes, you are going to be appending to everybody. That's yes.
Because that speak, it's common to all, right?
Yes.
Okay, it's okay.
Okay. So we have something we call inheritance. And inheritance is a process by which one class takes on the attributes and methods of another class. The new class that we form is called the child class. Like if I create a new class now that wants to inherit from this class, that will be called the child and this will be called the parent. Right? The inheritance is just like the meaning of the word inheritance. A father dies and leaves belongings to the children. The child is the one who takes the properties. That's the child. And the parent is the parent. So that's exactly the same thing here. When we have a new class, let's say for instance, we have a class called pet. So let's say class pet. And this pet inherits from the parent, which is person. We put this person class in the parentheses of this, in the parentheses of the pet class like this. And then we write all the definitions here. When you see anything like this, where one class has a parenthesis and names another class, this class pet is inheriting the properties and methods of the person class. Why do we use inheritance? We just want to use it to not redefine things. We want to make reference to the person's name, sex, race, or we want to use the definition of the properties and the methods within the person class, in the pet class. We just inherit them instead of redefining them here. Okay? So we have the init method, which is always the first thing that we should have. So let's say def init, and the first parameter is always self, like we know. And then we have the name, the sex, and the race. Now, instead of defining the name, sex, race, we just call the parent, which we use super to do like this. So we're saying that the definition of the name, sex, race is the same definition that we have in the init method of the parent class, like this. So we're using the name, sex, race definition from the parent class. which is person. Okay. Now let's say we want to have a new parameter called type, for instance. So let's say we have a type parameter. Let's say self.type. Let's put type here. And then we'll say self.type is equal to type. So we don't want to define name, sex, and race because it's defined in the parent class. We just use super to say the definition of all of this in the init method of the parent class, and then we define the type that we do not have there. So we inherited the properties from the parent class. This is just an example. It might not make so much sense, but we need something to define. Now, we want to have maybe the default for the type is dog, for instance. And let's say self.type, instead of type here, we can just say dog. So let's say in the event we don't specify this parameter, we just want to give it a default value, we can just remove this and say self.type is equal to dog. So you can see that many ways you will see this exist. Either you want the person to supply the argument when the object is created and specify the type of the pet, or you want to have a default like this without having to put that there. If we say we want to use get the languages that the dog speaks here, from the parent class, we can have something like, let's say super.speaks. Now, because we've already appended English and Spanish and French there when we did the other one, so we only have English now because I deleted the other code. But I want to put the language for the dog. I want to still use the same speaks class attribute here. So I will say, let me clear it first. So I will say super.speaks.clear, and then I will say super.speaks.append back. Now, this is not the best method. I'm just illustrating things. When we begin to build our software, we'll do this more correctly. If I go straight to the Pythonic way of doing these things, you'll get confused. So I just chose the easy route out and say, I want to clear everything held in this speaks class attribute. And I want to now put the language for the dog, which is back. Okay. Then I want to create a new instance now for...
Hello, ma'am.
Yes?
Now, because of inheritance, you have to use that .clear to negate it so that it won't inherit the speak, right?
Yes.
Okay.
So that we will not get this English language. So just clear out the language there.
Okay, it's okay.
So this one, the language the dog speaks is back. And then let's say we want to create an object of the class. Let's say my pet. So my pet will be equal to, we call the pet class. Let's say the name of this pet is a dog. So we say the name is Bingo. And we say that Bingo is a male dog. And let's use the race as the breed of the dog. So let's say Bingo is a German Shepherd. So you see how we have defined the dog. And when I print my pet, it's going to use the introduce method that we had there, this self string here, representation. So when we do this, we'll say, hello, my name is Bingo. I am a male German Shepherd. So you now see how inheritance makes these things beautiful. You don't need to redefine methods or functions within the class that inherits. There are several things that are similar between the pet and the person. We want to inherit the properties and the methods and use them in the pet class without having to redefine them because the person class has it. This is what we call inheritance, and this is what inheritance is all about. Does everybody understand?
Yeah. To a very large extent, I got what you're trying to do. One would just need to go over it again to get a full grasp of everything.
Yeah.
Yeah, I got what you're trying to achieve. Thank you.
All right. So we will end this lesson here today so that we don't have too much content to remember. We are going to have another live class on Tuesday next week. Invitation will be sent out a day prior that we can discuss the collection types and list and all the other the collection module that will give us a deeper understanding of all of this that we have done. So we have a live class for batch B of course 3 on Tuesday, and we'll also make that a combined class where we can go deeper into Python so that we can continue to get deeper understanding of all of these topics that we need to tie together into our software development project. If nobody has any questions or comments, this is where this lesson ends. So I assume that everyone is okay. So have a wonderful weekend and see you next week.
Thank you.